All right, Falcons, we are working with volume of prisms and cylinders today. Hopefully you watched the first two videos in the slides that gave you an idea of volume and an idea of prisms and cylinders. So we're going to go through these guided notes together. The formula for the volume of any prism or cylinder is capital B times H. B stands for area of the base. We use a capital B since it's two-dimensional, and H stands for height. There are some times that it's not necessarily from floor to ceiling height. It might be like a length or a distance that we're extending it by. So before we actually start taking the volume, let's recap what our area formulas are, because we need to use those when we find the volume. So any quadrilateral, like a rectangle or a square or a parallelogram, is going to be little b times H. Or maybe you write it as length times width. It's just the two pieces multiplied together. A triangle is base times height divided by 2. A circle area is pi times the radius squared. And a regular polygon is the apothem times the number of sides times the side length, all over 2. So here is our first shape. If we look at that shape, we have a triangle that is being extended 2 centimeters. So the name of the base is a triangle. Since we extended it, we call it a triangular prism. In order to find the area of the base, I need to recall that the area of a triangle is base times height divided by 2, but we only care about the triangle. So the triangle is this blue piece, which means my base is 4, my height is 10. So the area of a triangle is 4 times 10 divided by 2, and you can put that in on your calculator. It ends up being 20. Remember, area is going to be centimeters squared because it's two-dimensional. So all I need to do to find the volume, remember, it's capital B times the height I'm extending it. So capital B times H is going to be 20 times 2 to get the volume of this triangle. So 20 times 2 is 40 centimeters cubed. That's how we find the volume of that triangular prism. Example B. This time, the base that we have is this circle right here. So the name of the base is a circle. Remember, we don't call it a circular prism because a circle is not a polygon. So instead, we call this shape a cylinder. You probably work with a lot of cylinders, a lot more than you realize, like paper towel rolls or pop cans or soup cans. So to find the area of our base, we need to remember that the area of a circle is pi times the radius squared. If we look at that circle, the dimension they give us is 6, but that goes all the way across. So 6 is really the diameter. In order to find the radius, we have to divide the diameter in half. So my radius is actually 6 over 2, which is 3 yards. So in order to find the area of just that circle, I'm going to do pi times 3 squared. In your calculator, we want to make sure we use the pi button. So the pi button is second up, and then we had 3 squared. So the area of my circle is 28.3. I'm going to leave that in my calculator, though, and make sure that I don't clear it. So 28.3 yards squared, because it's area. In order to find my volume, I'm going to take my area of the base and multiply by what it's being extended by. It's being extended 21 yards across. So I'm going to take my answer from the area and multiply by 21. So to do that, I can just hit times 21. When it says ANS in the calculator, that means it's using your previous answer. So that 28.274333388 and so on is what we're using. So my final volume is 593.8 if we round to the nearest tenths. And since it's volume, it's yards cubed. All right, my next example. Ooh, fun times. We have a regular polygon. So if we count those sides, 1, 2, 3, 4, 5, 6, we have 6 sides, which makes that a hexagon or a regular hexagon. Since we're extending it by that length of 5 centimeters, we'll call it a hexagonal prism. This one's going to be a little bit trickier, so remember to find the area of a regular polygon, we do a times n times s divided by 2. We don't know what the apothem is, so we're going to have to find that, but we do know our number of sides is 6, and our side length is 8. To find our central angle, we'll do 360 divided by our number of sides, which is 6, divided by 2, to give us a 30-degree angle. So if I wanted to make my little triangle in here, that angle will be 30 degrees. The piece that I know is the side length, which is 8, but remember when we're finding the area of a regular polygon, we're only using half the side, so this piece is 4. So let's go ahead and label our triangle with our trig letters. We have our hypotenuse, our adjacent, and our opposite. Our goal is to find this piece right here, our apothem, so we're going to use tangent. Tangent of 30 degrees equals my 4 over my apothem, or x. You can use a or x, which means to get that by itself, I'll do 4 divided by tangent 30. In my calculator, 4 divided by tangent 30 is 6.9. So my apothem is 6.9. So in order to find the area of that polygon, I need to do 6.9 times 6 sides times a side length of 8 divided by 2. That gives me 165.6 for just the area of the polygon. And remember, area is always going to be units squared or square units. So to find the volume of this shape, since it's a prism, I'm going to take that base that I got, that 165.6, and multiply by my height. That ends up being 165.6 times 5. So I'll go back to my calculator and just do a short little times 5 to give me 828. And remember, our volume is always cubic units, so that's cubic centimeters or centimeters cubed. And the last one we will do today, before you get time to practice on your own. This time it says a cylindrical container. That lets us know a keyword, cylinder, with a radius. I'm trying to underline, but my smartboard's not working, so sorry about that. Radius also tells us we're using circles of 8 centimeters. So I got my circle. The radius is 8. Is filled to a height of 10 centimeters. With sulfuric acid. The density of the sulfuric acid is at 1.84 grams per cubic centimeter. What is the mass of the sulfuric acid to the nearest gram? Whoa, whoa, whoa. A lot of that was extra information, so I'm not going to worry about that second piece until I at least find the volume. So the shape, or the base, or I guess the name of the shape ends up being a cylinder. They told us it was a cylindrical container. It also had a radius base, so we know it's kind of like a prism. The area of the base, remember the area of a circle is pi times the radius squared. So in this case, it's pi times 8 squared. Let's go ahead and get that on our calculator first. Pi times 8 squared gives us 201.1. And again, since it's area, it'll be centimeters squared, or squared centimeters. To find the volume, I'm just going to take that base, which was 201.1, and multiply it by the height it's extended, so 10. Base times height. I'll go back to my calculator and multiply by 10. That gives me 2010.6. So I can fill this cylinder with 2010.6 cubic centimeters. Now comes in this extra piece about that sulfuric acid. So since there are 1.84 grams per cubic centimeter, that means there are 1.84 for all 2,000 of those cubic centimeters. So I'm going to take that 2010.6 and simply multiply it by 1.84 to get the mass. So I'll go back to my calculator, multiply by that 1.84 to convert it to the mass, and I get 3,699.5. 3,699.5 grams. Go ahead and work on the rest of your prism and cylinder practice. It's a two-sided sheet. If you have any questions, email your teacher.